Okay, last problem, 10.7. In the absence of air resistance, a projectile is fired 45 degrees and that will give us a maximum range in the absence of air resistance anyway. So it says, what is the initial velocity in order for the projectile to go 20 yards and 40 yards? So it's going to be two different numbers right there. And let's go ahead and just use that the acceleration in the y direction is negative 32.2 feet per second square. So why do I use that rather than negative 9.8 meters per second square? The answer is because it says yards here, so feet seems to be a better choice. Also, we can say that the acceleration in the x direction is equal to 0 because in a projectile motion free of air resistance, the only acceleration is in the y direction. The next thing you do is you just kind of go at this blindly and write down your kinematics equations and figure out where to go from there. So the x component of the velocity is equal to the initial x velocity plus axt. This is from the first page of the homework handout. And put a y right there. I'll keep putting that square there. I'm not sure why I'm doing that. All right, and then x equals x naught plus v naught xt plus 1/2 axt squared. And then y is equal to y naught plus v naught yt plus 1/2 ayt squared. So that's where the square is. Let's look at what terms are 0. You can assume you start at the origin, so we'll put our origin here with y like this and x like that. If you do that, then that is 0, and this is 0. Also, since we're talking about a projectile motion, the acceleration in the x direction is 0 there, and 0 right there. Okay, now what? Well, we're trying to figure out what v naught is. So it looks like what we're going to have to do next is say that v naught x is equal to v naught times the cosine of theta, which we know to be 45, and v naught y is equal to v naught times the sine of theta. Now we don't really get anything out of that one. It just says that the velocity in the x direction, that component is constant throughout the flight. And you can kind of see that maybe if you look at the component here, component there, and then you see the x component is always the same, but the y component is the one that's changing. So same for the x component, but the y component is getting shorter, 0, and getting longer in this direction. So that's all that's really saying, not getting much out of that one. What we can do is play our game here at the top, though. Maybe we'll get somewhere with that if we say at the top. We'll see what we can get out of this. At the top, the y velocity, as we see in our sketch here, is equal to 0. So 0 plus, oops, not plus, equals v naught y. We said that that's equal to v naught times the sine of theta. Plus ayt. We know what the a is, but we don't know what t is. So let's use maybe this one, because we know how far it goes, 20 yards or 40 yards. So let's see what we can do here. This one would not be at the top. Maybe we can say at the end, at the end of its path. We can say that it travels a distance d, make it specific to the problem, and v naught x becomes v naught sine, no, v naught cosine of theta, t. Oh, that's it. There's 0 here and 0 there. Well, that's kind of nice, because it looks like we have two equations and two unknowns. So let's see how we can quickly wrap this up and get to a solution. Well, on this one, if you simplify this one by solving for time, you move this to the other side, negative v naught sine of theta, and then you divide by ay. You substitute that in here, and you get d is equal to v naught times the cosine of theta times negative v naught sine of theta over a y. Okay, looks kind of difficult, but not really, because what will happen here is that a sine over a cosine becomes a tangent. So this becomes, I'll just do it like this, negative v naught, and I got that squared, and the sine, oh no, I'm sorry, that's not sine over a cosine, is it? It's just sine times sine. Okay, that's fine. So sine theta, cosine theta, it's not tangent, my bad, over ay. Okay. All right, that's not so bad, I guess. So the final step is to say that the velocity in the initial velocity is equal to d, right there, times ay, and we also have a minus sign we can pull over there as well, divided by sine of theta, cosine theta. Hope I didn't make any mistakes here. Oh, square root, because it's v naught squared. Check that over to make sure it looks right. The reason it looks like you might have a minus under the radical, but you really don't, because ay is negative 32.2 feet per second squared. And the units work out too, so your answer is going to come out in feet per second, as I have it right here. Now, what do you use for d? Well, for the first one it says 20 yards, so you just multiply that by 3. So you put 60 feet right there. You put negative 32.2 feet per second squared, sine of 45, cosine of 45 square root. And then 3 times this one for the other one. Hope this helps.